Okay, we're gonna do just a couple of real quick voltage and output tests on this thing. Now, I'm gonna start this with one of the things that I don't like about this turbine. Lots of things are galvanized, and the galvanizing is actually pretty good. This thing has been up in the air for a while. Very little rust on it, except here. Now, normally doing these tests, I would prefer to take the hub off and not have this thing spinning around. But because the shaft going through the rotor and the nut, none of that's galvanized, none of it's stainless, so it's all rusted together. I've actually stripped out, I messed up several Allen wrenches, and now the socket is just completely toast. There's no taking that off. I'm going to have to cut it off, and then even then might damage it. So that's one thing that should be better. That should be stainless, or at least much better galvanizing than what it has, or zinc plating, something other than just bare steel. I'm willing to bet I could probably get it to loosen up with some heat, but the blades mount right on top of it. I can't access the nuts easily to get the blades off with the hub still on it. It's just, that's a pain. So we're gonna do the voltage test in the most irresponsible way imaginable, and I'm gonna spin it up with the blades on it. So it'll be a little bit noisy and give you guys a little bit of an idea about the noise it'll make just in dead air. I don't know if I'll be able to get this to where we can see on camera the meter. Let's do it from here. Let's see if that'll do it. Will the meter be visible there? How can we stick it here? Put this here. A welding clamp that I need to put on my welder. All right, let's see if that's a good view. But we'll be able to see a little bit. All right, so this is just open voltage test, and of course I won't be able to see it at the same time, but whenever I did this a minute ago, it was 24 volts, as high it would go as this drill could get it, which is right about 800 RPM with this wheel on it. But that is about what I expect from this machine, but just so you guys can kind of see the voltage per RPM. I'm going to try to spool it up slowly. There's a lot of resonance. I don't know if that's going to show, but I've got it clamped to my vice grip or bench vise, and you can just hear it all through the building. The idea that these are no cogging motors is inaccurate. Actually, I want to look a little close to something over there. Okay. And I can't catch the camera. Did you enjoy the ride? Okay, so I'm willing to bet that that was right around 24 volts. That's what I was seeing earlier. And that's, let's do it again from this side. Because that side, if it was blowing the camera over, probably a little bit of wind noise. It might hide the sound of the blades. The blades do make quite a bit of noise. If I do this right, that might still be visible. Doesn't do any good to be able to film in 4K if it's not high enough resolution to see the screen. All right, one more time. We're going to spool it up real slow. Again. We're at 3 volts at 1 or 60 RPM. We're at 12 volts at about 120 RPM. Whoa. Now you can see it makes quite a little bit of humming whenever it's going. All right, so that's our open voltage. I'm going to actually run it to this cutting edge 600 watt inverter that's up here, which I thought was tanked before, but I put a little bit of power to it the other day, and it seemed to kick something out. So we're going to see if it will do anything at all. And we're going to run it to this gauge right here and see if, oh man, I won't be able to turn my camera. Okay, y'all just have to hold your head sideways. See what happens. Make sure I've got that one going to the right one. This one. I need to label my plugs. Okay, so that's all on and ready. Okay. Let's see what happens over here. Right now I've got it on run. So I'm going to turn it by hand just a bit. Let's see if we get any real quick, easy output. I'm not going to be able to turn it fast enough that way. Okay. All right, back to the drill. We'll see what happens here. I couldn't quite see my screen, so I don't know what it was showing. You guys had a better view of that. It didn't look like a whole lot. We're going to try that one more time. So it looks like it was doing about 60 watts, I think. Now, that drill should really be good for a little bit more than that, but it's getting a little warm. So maybe that's just all it can do. Let's see if I've got one of my meaner drills in here. And I don't. So that's what we've got to work with for now. But it is at least hitting charging voltage. Well, my drill could turn it right there. It really was not going very fast. But with 7 blades, it should be able to do, you know, it should be able to get a little bit more torque out in the open wind. And now, like I said in the other video, this turbine came from a friend of mine. He bought this and a few other things to try and run a well, and the turbine never got put to real work for him other than charging a couple batteries. It's mostly sat in the air, freewheeling. He said he kept his batteries charged for a while, but then the slip ring failed. And I've got, well, actually, no, I'm sorry. And then it sheared all the wires off because this turbine was not sold with a slip ring. And I know a lot of people say, oh, you don't need a slip ring. You can just go and untwist a wire, once a year. But out here, if you try to do it without a slip ring, you're just going to break your wires. So we got a slip ring for it. I'm going to put it out there on the pole with where the Tessep was, where the Chinese 700 was. You know, I'm just looking at the tips of the blades. They're very sharp. And they got casting lines all down like the seam. It's very sharp along the edges. But it does look like a decent airfoil. I've heard the thing, actually seen it running, so I know it does actually turn. I don't care much for the finish. I know that Missouri Wind says that these blades are made out of the same stuff that next generation fighters are made out of, but it really is. It's just if it's carbon fibers in there, it doesn't really make a difference. It's a fiber reinforced nylon blade. That's just what it is. And I'm sure that there's stuff on F-22s and such that are made out of similar materials. But you know what? There's also stuff made out of similar materials in my phone. So that's just gimmick. I still haven't found, like the blades say Raptor USA, but I still haven't found where these blades are made. Need to look a little bit more into that. And another thing, it's advertised that these motors don't cog. That's cogging. And anybody that says that's not cogging is lying to you. But looking into it, I don't know if we'll be able to see in there. They are great big magnets. It's wound with, pretty decent sized wire. So there's at least a pretty good bit of potential there in the stator. Yeah. I'm looking forward to seeing what it can actually, produce over time. Would be nice if it were a 24-volt turbine. But oh well. Can't have everything. So that's that for now, guys. Thanks for watching. There will be another update soon whenever I get it out here on the pole. I'll get the remnants of the Atlas down and put the... Missouri turbine up there. I also have the I-1500. That one's been repaired. It's back up finally. I haven't been in a hurry for that one because I haven't had, you know, new inverters and stuff for my board. They're supposed to be here within the next couple days, and hopefully after the 4th, I'll be back up to running like normal. So that's that for now, guys. Thank you all for watching, and I hope y'all have a wonderful day.